Hello and welcome back. Now before we get started, I did want to point out just in the community tab on my channel, I did sort of ask before I started the series just what we sort of want to strive towards in terms of a game that we might build with this engine. So the end goal really being that we can build one of these sort of styles of games. So just let me know down here by just clicking on these. It looks like currently couch co-op style battle game is winning. Let me know what you want out of this and we'll build something when we get to it. Today we're going to focus on splitting up our project so that we have an engine project and then our editor project. And we're going to be able to link to our engine from our editor. But before we get to that, I really want to focus on the tool pipeline for a second. One of the things that I'm sort of not happy with right now is, for example, if I was to modify my main.cpp and add something here that would not compile, and I'm chaining commands together, so we'll do a build sln and a run. What this will happen is it'll try to build, it will actually fail to build, and then it will still run. And in this case, it'll actually run whatever happens to be in that directory. It's not going to fail the run or anything like that. It's going to run up the previous version of whatever succeeded last. And that's not really great. I think if I'm chaining commands like that, I definitely expect my run to show me the new thing I just built. And in this case, obviously, there has been a build failure. So I want the whole pipeline to stop here. Every time a script or a tool finishes it with a non-success sort of return code, I want to be able to capture that and stop executing anything else. So we're going to clean that up real quick before we get into the project sort of separation work. So to do that is pretty straightforward. We just in Python, so I'll just work my way from bottom up. In Python, if we import sys, with sys, I'll be able to actually provide an exit code, a return code. So when the script is finished, whoever has run this script can actually listen for that return code. And we do that with a sys.exit call. And 0 usually means that everything is happy and no issues were found. So let's just do that for all of our scripts, and then we'll update our CLI.py to actually take that in and do something with it. So just working my way up, I'll just import sys. And obviously the version was very easy. Here I think what I'm going to do is, because we're calling something external, we're going to have to actually update, so maybe I'll have a ret equals 0, and then subprocess.call. This will, this will actually return the error code that this returns. So I just say ret equals, and then I can just say sys.exit ret. And what this will do is it'll just ensure that whatever, since I'm calling another process from here, whatever it returns, I'll return out of this. So if there's any failures internally, this will capture the failure in the run command. For globals is fine. Gensln, same thing. So we'll import sys ret equals 0, and then ret equals. And actually for this, I don't want this, because if this fails and this succeeds, I'm not going to catch that this failed. So I'll say if ret equals 0, and then I'll just do that. Sys.exit ret. And build sln, same thing. So import sys ret equals 0, and ret equals, return, sys.exit ret. Okay, so that should be all we need to do here. And I think just now our CLI.py needs to actually do something with these values. So coming to the top, let's clear these comments here, clean this up a little bit. So yeah, this is going to loop for everything, and run command is going to, it currently doesn't return anything. I think I want run command to tell me if everything is good, basically. So I'll just have run command return that same error code from subprocess.call, because again, this is just going to call this Python with our script, and it will return whatever our sys.exit was from each script. So I will do that, and assuming I've done that, I will just say I'll break out of the loop if it's not equal to 0. So if run command does not equal 0, then we can just break. Yeah, that should do it. And so then up here, we'll just actually have to capture that. So let's assume, let's say ret equals -1. Let's assume it's not happy. And then we'll just say ret equals subprocess.call. The reason I assume it's not happy is because if the path doesn't exist, this will happen. And I mean, I guess I could assume it's happy and then just set it to -1 here for specifically that. That's actually probably better. Let's do this. So ret equals 0, ret equals subprocess.call, and in the else case, we'll just say ret equals -1. And then we'll return ret from this function. And what that should do is just take, again, the output of the subprocess.call and return it, or -1 because we have an invalid command. So this should actually be all we need. So I've saved everything. So if we try this again, actually, did I? Yeah, it's still broken. So if we try this again, there we go. That's perfect. So it built and then it did not run. Similarly, if I tried to do like a misspelt, a misspelt one, invalid command build SL, and it doesn't go on because I've explicitly said in my CLI.py that this means a -1, so that will stop execution. And obviously, if I have a proper one, gensln in the front, and then a wrong one in the middle, it'll just do gensln, it'll fail here, and it will stop. So that's perfect. That's the one piece I wanted to clean up before we move on. So let's just switch main.cpp back to a fully functional CPP file, and everything should still work. If everything succeeds, it will run through everything. Okay. So what the main focus of the video today is it's going to be breaking out our project into two separate projects. And if we just look at our premake5.lua file right now, we have this hippo workspace with a hippo editor as the start project. And that's fine, that'll stay as is. But obviously we just have the one project, hippo editor, and it just has its definitions in here. What I want is to pull out all of my engine logic and my engine sort of code out into its own project as a library that I can then link to from hippo editor. And the reason we want to do that is because we want the engine code to live in its own place, so that, for example, if I have my hippo editor that's running using the engine, I might have a hippo player maybe that plays, it's just a player for the game. So the hippo editor is used to build the game, and a hippo player might be used to just play the game. It doesn't matter how I'm running the game, I still need the engine. That's obviously the core of what makes up the game and what allows it to play. So that's the reason why we're going to split it up that way. And in this case, I'll just have another project, and I'll call it hippo. You can call it like hippo engine or hippo lib. I think hippo is fine. And so again, similar to before, so we'll do our location is hippo. So we'll have a hippo editor folder, just like we do here with its source code, and we'll have a hippo folder with its source code. So here it's console app, and that's fine, that'll stay. For hippo, we're going to want a library, and specifically we're going to do a static library. And a static library just means that we have the code compiled into a .lib, which we link to from our hippo editor. And that ultimately means that the code ends up embedded in the .exe. It's not like a DLL that we're linking to dynamically, and that's sort of the difference. And you can read about static versus dynamic linking online. We're going to do static lib here. So kind is static lib. The language is C++. Just copy this. CPP dialect is going to be the same. Writing this in C++ 17. And then one of the things I want to make sure I do is, if you've used Visual Studio before, there's like the debug, like the /mtd or /mt, the non-debug sort of linking. And what we want to do is ensure that all of our projects that are being linked together are all statically linked, or they're going to be static runtimes is what it is. And so that's what we're enabling here, static runtime. We're going to enable it with on. And we want that for both. And this will just ensure that there's no mismatches in the dynamic runtime or static versus dynamic runtime setup for these two projects. So that's good. Again, we want the target directory and the object directory to be the same because it's going to use the build config and the project name. So it'll end up in its own folder. And that's fine. That's exactly what we want here. And then for files, I think we just want the same thing. So files, we'll want the same flags. So yeah, I'm just going to copy this from here. So one of the things though that I'll add is the way I usually structure these sorts of libraries is you'll have the source directory, which is basically completely obfuscated from anything that's linking into it, right? You'll see this everywhere with any static library or even dynamic library that you link with. You'll usually have header files that define sort of the prototypes of your functions and sort of the layout of the project, and everything sort of gives you the interface to actually call functions on the library. But the actual source code is not going to be available to sort of the code that's being written in the linking project. it's actually just going to be in the .lib, and the linker at the time of linking your project will figure out sort of where everything is. So anyways, all that to say that I usually have an include folder, which has header files in it, and then I'll have source directories. And source directories might have header files. There's nothing wrong with having sort of a hidden header file that external projects can't see. But basically anything in the include directory is going to be everything that we're going to expose to this. And you'll see how we do that once we get down to that. But yeah, so our files will have the include directory with every header, and that's recursive, and then everything in the source directory. Now here, because they're going to be in different folders, we want basically to define that this is an include folder. So the way you set up your projects is you give it the paths to your include folders, and that allows you to write code. For example, I can say include engine.h, or I might have to say include hippo/engine.h, depending on where we are. And if I say that hippo is an include directory, then I don't have to type hippo every time, I just type this piece. So that's what we want, and we do that with sysincluders. And for now, it's just going to be basically our own path. So prj .name, project name /include. So I'm going to include this from here. Okay. And then, yeah, we have our flag set up, so that's good. The only other thing I need to do now is, so given that this project is done and it's a static lib, I want hippo editor to link to it. And I'll do that with a simple links hippo. That's all you have to do. So links is saying that hippo editor will attempt to link with the hippo library, and hippo is just this project name here. So Premic will figure that out for you. And then similarly to what we did here, like I said, we're only going to expose the include folder to hippo editor, so we want the same thing. Sysincluders, and instead of project name here, we're going to have to hardcode hippo, unless I have another library, value up here that can define like the hippo, sort of the engine name or this project name in a way that's reusable. I don't mind, I'm not going to change the name, so I'll just hardcode hippo down here. So hippo/include is what this will be sort of exposed to. And in this include folder, we're actually going to create another folder called hippo, so that I do write hippo/ when I'm writing that sort of code from hippo editor. Okay, so I think that's all we need. We probably want the source directory as well, in case we have header files in there as an include directory. It doesn't mean we're going to try to include CPP files. Obviously, we're not going to try and do that, but just in case we end up with header files in here, I also want those to be accessible. But you know what, maybe we'll keep it like this for now, and if we ever do this, we'll come back and add that. Because I don't know if there's going to be any clashing between that, so we'll just leave it like this. So this should be all we need. So in order to actually see what this does, I just have to gensln, and it's done. That was quick. Here's a hippo folder with the hippo project. So that's good, but there's nothing in there yet. So we're going to have to create something. So again, I have our source folder. Oh, sorry, I have here, I'll create a source folder, and I'll create an include folder. Source and include. So include, again, I want this to have hippo, not jippo. Here, I want this to have hippo, because I don't want to include things like engine.h like by itself from hippo editor. I want it to be explicit that I'm including something from hippo. So I'm going to have include hippo, and I'm going to have source file. And what I'm going to add here is something, let's just call it engine.h. Very straightforward to start. And in the source folder, I'll create my engine.cpp. Okay, and this is sort of the start of sort of the differentiation between our engine code and our editor code. And so obviously for now, we're not going to focus on anything too crazy. Let's just add some functions here. So we'll pragma once at engine.h, and we'll have a namespace. Everything in hippo will be behind the hippo namespace, so we'll do that. And let's just let's do a couple tests here. So let's do like an int sub, int a, int b, and maybe we'll make this one inline, just to show the difference between having everything in a header or referring to the CPP and seeing that it works in both cases. So this inline will just return a minus b. And then we'll have a non-inline, so int add maybe, int a, int b. And this code will actually not live here, it will live in the engine.cpp. So we'll do that. In engine.cpp, first thing we have to do is include, and because I set up my include directory at, again, the include level, we'll need hippo. And I guess if we wanted to make this easier, because we're in hippo, we could actually just have our includer here be include/hippo, so that we don't have to type hippo every time. That actually makes sense. I think I want that. So I'll do that. I'll just gen-SLN again, just to make sure we pick up those changes. And then, yeah, so all I have to do then is include engine.h. And you can see, looks like this Visual Studio Code just picks that up, so that's good. And then again, namespace hippo. And the only thing we have to define in here is the add function, right? So we're in the namespace, so we just have to say int add. Was it int? Yeah, int a, int b, and then return a plus b. Okay, so we have defined sub and add. They are both defined and they have bodies, and that's in hippo. So now what I should be able to do is from main.cpp just include, and again, at this point we want to include things with hippo first, right, hippo/engine.h. And this is because the include directory for this project is at the include level, so that I can be clear and specify that this is a hippo file. So we'll include hippo.h, we'll say hello YouTube, and then maybe we'll just have int a equals, and I just want to call those functions, so we'll say hippo : add 10 and 5, and then int b equals hippo : sub 10 and 5, and we'll still see out that a b return 0. So this will be the sort of major test, right? So can we build hippo as its own project into a .lib, and can hippo editor link to it properly and compile this code? So we'll gen-SLN again, just to be safe, build SLN and run. If we do everything back to back, it should just work. So you can see it's building hippo.lib right there. Yeah, there we go. So let me just scroll up a little bit here. So it builds hippo.sln first. Oh, sorry, that's the solution. And it's got 2 projects in it. So wait, where did it build? What did it build first? It's building hippo first for sure. Yeah, it's building hippo first for sure. And then down here at the end, it's done building hippo.vcxproj. So it's done. And that was building this. So this created hippo.lib within that output directory. Remember that bin debug hippo.lib. And then it goes on to, so it's done building the first project, it'll go on to building the second project, and which is this, just has a main.cpp, and then it'll link to it. And you can see it links to the hippo.lib, it knows where to find it, and then its output is hippoeditor.exe. And it's done, and then it's done the entire solution. And you can see that worked. So we have 15, which is 10 plus 5, and 5, which is 10 minus 5. So that's pretty great. And again, if we just inspect this we have bin, debug, and then we have our 2 folders. So we created this hippo.lib. The PDB is the symbol, debug symbol, which is what allows us to, because we're building in debug, we build these. That's fine. That allows us to put breakpoints and attach and things. So that's hippo, and then hippo editor, you can see we don't have hippo.lib or hippo.dll or anything like that. We just have the hippoeditor.exe, and that's exactly what we want. The hippo lib is included and sort of packaged internally within the hippoeditor.exe. And the linker is what uses hippo.lib to be able to figure out where the actual code lives, because hippo.add is not part of this project. So that's it. That was pretty easy. And this is sort of laying the groundwork for us actually being able to write engine code in its own project and then write editor code in its own project. So now that we've done that, I think one more thing that I want to do here is if we look at our premig 5.lua again, you can see we have configurations, right? Debug and release. That's great, but we don't actually define what the difference between them are right now. Like, we just say we have 2 configurations, but we don't actually say what the differences between them are. We also don't do anything specific to the platform or specific to the configuration that we're in, obviously, as I just said. So we're going to want to add that to both of our projects. Basically, what I'm looking for is the ability to have basically a define that would be defined if we are on Windows or Linux or Mac, for example. Because sometimes when you're writing engine code, you're going to need to know which platform you're on, because you need to know sort of how to do something. Let's say, for example, we're doing something with time, and we need to include something for time, and maybe it's different across both, across a Unix versus a non-Unix platform. We're going to need to write platform-specific code at that level, and obviously our engine will obfuscate that from the user, but the user in this case would be the editor and eventually a player. But we do need to know what platform we're on. Right now we don't have a way to do that. So the best way to do that, at least the way that we can set it up very easily here, is to use these the configurations and the platform we're building on to actually define something at the preprocessor level, so that our code can actually refer to those defines and just check against them. So we'll do that real quick, and just under everything, I'm just going to add to this. And what you can do at the project level here is you can start adding filters, and you can do code, basically write code for only the situations in which those filters apply. So you just do that with a filter, and the first thing I'm going to do is just do a Windows filter. So if we're on Windows, here's what I want you to do, right? The way you do that is you'd filter on the system. So system, and you'll say system:\Windows, and that's how you define that you want that filter. And then you can also define configuration. So again, the debug versus release piece. Or you can define it like for both, and that's what I want in this case. I don't care what configuration we are, we'll do that separately. I just want to know that we're on Windows. So you can specify that with configurations, :0, or sorry, :*. Star is the wildcard, so obviously it means anything. So within this filter, I want to add, one of the intricacies with the filters, depending on where you are, you might have to define the system version. And I almost forgot about that. I think that wouldn't have worked. But either way, for Windows, you just want to say system version is latest. Oops. Latest. What this will do is it will sort of, as your, you get Windows 10 upgrades, and sometimes you have to update your code to target the latest Windows SDK. That's what this will do for you. So whatever the latest system version available is, every time you regen SLN, it'll just target to that. And that way you don't have to keep, you won't have an out-of-date project, basically. So we'll do that. And then what I want to do for Windows is I want to add a define, right? So I don't think we've done that before yet. So the way you do that is just defines. And then you just define a list, just like we do with our flags. And I'll just say hippo_platform_Windows. And this will be a preprocessor define that we can check against in our code. Cool. Now I want to do the exact same thing for all three platforms. So the way I'll do that is I just copied and pasted it here, and the system is now Mac OS X. Again, every configuration. Now this is a little different, and this took me some digging to find out, but I'll just tell you what you have to write here. So with Xcode, you have to write something specific, and this will only apply to if you're building Xcode. I know we're building both right now, GMake and Xcode. So if we're building Xcode, we're going to define Xcode build settings. And Xcode build settings will have two things in it, and this is the way you write it. So Mac OS X _deployment_target. This is basically the Mac version you're targeting. It doesn't have to be the latest. It can be something that is not latest. It might show up as warnings in Xcode, but that's fine. And sometimes you actually want to target something earlier than the latest thing in case you want to include people that don't have the latest hardware or the latest software to support the latest hardware, or vice versa. So in this case, we're going to do Mac OS X deployment target is, we'll just target 10.15. You can target 10.14, 10.13, whatever. It doesn't really matter, but we just pick one, and I've chosen 10.15 here. Additionally, with Xcode, there was something new. It was called the modern build system that was turned on, and it actually is causing issues on my MacBook. I'm not sure about everybody's MacBooks, but my Xcode is not happy with that. So I have to tell it not to use this modern thing and just do it normally, or whatever the old way was. That's the way that it's going to work. And you just tell that, it's just a flag, so use modern build system, and you'll say equals no. And in your Xcode, I forget what the file extension is, but there's an Xcode like project file, just like your Visual Studio project files. And if you actually open that in a text editor, you'll see these sorts of things. You'll see all of the flags that it's sort of setting. So if you ever want to find out how to change something, within Xcode through Premake 5, just open your project file open Xcode with your project, make the change you want, for example, target or something in Xcode, and save your project file, and then open that project file in a text editor. And you'll see it's all plain text, it's like XML or something, but you can probably scroll through it and figure out what it is. That's how I found this one. I told Xcode not to use modern build system. It was originally using it by default with this Premake system. It would actually not define this, which means it would set it to yes as by default. Anyway, so if you want to do any other project changes, you can just look at that and just add it here. and this will directly impact that Xcode project file. So that's what we want to do here. It's sort of the Xcode version of system version latest. And then defines, again, now we don't want Windows, we want Mac. I think I'll just leave it Mac, not Mac OS X or anything. Just Hippo Platform Mac. Okay, and then Linux, funnily enough, Linux is the easiest one of the bunch. With Linux, we just have to say, so we'll write Linux here. And we don't need to specify anything here. This is just plain old make files, they'll work just however you want them to. And we'll do Hippo Platform Linux, I think. Yeah. Okay, so that's all we have to do for being able to check what platform we're on. Now what I want to do is sort of check what configuration I'm on. And the reason I want to do that is because I want to, for example, turn on optimization, or maybe I want another define that just tells me if I'm on debug or release, because I might have some debug code that I don't want packaged into my release builds, right? So again, it's just a filter. In this case, you can do system star again, or you can just omit it. I did configuration star up top. I'll just omit it here for this time. And yep, again, it's just configurations, colon, and in this case, we'll do debug, because that's what we called it up here. We called it debug. So for this, and if you use squiggly brackets if it's a list, you can actually omit them if it's not a list, so we can just do it this way. And the way it works is, again, top to bottom. So any filter that's defined, everything below will apply until the next filter, then, obviously. So here, configurations, debug, I want to define, and again, it doesn't have to be a list like this, but I like to do lists because if I want to expand it, I can just do it quickly. And so here, I'll just do a defines, and I'll call it hippo underscore config underscore debug. So this is what the flag will check in the code if to know if we're in debug. And then here we'll set the runtime. So the runtime will be debug, and the symbols will be on. And this is what I was talking about above, the PDB, these debug symbols. Symbols on means they'll be created with your, alongside your project. For release builds, we don't want symbols. We don't actually want to expose that. So we're going to have another filter for configurations, colon release, and defines, again, hippo config release, and then we'll say the runtime is release, and symbols are off. And one other thing we can do here for release builds, we want to turn on all the compiler optimizations that we can. Because we don't need to debug code, we don't need to step through anything. This is a release build, right? The point is it's what I'm going to release to people. So we want to optimize everything as much as we can. So optimize on. That's just turning on all the compiler optimizations that it can do. Okay, and obviously by default it's off, which is why we don't have to specify it up here. So that's pretty much everything. Right now we should have these preprocessor defines. What I do want though is the ability to use these from anywhere. So these preprocessor defines will apply to the project you're building, right? But I also want to be able to check against that in my Hippo editor project, because I might have, again, maybe some debug code that I don't want packaged into the release builds. Similarly, I want the ability to say Hippo Platform Windows, Hippo Platform Mac, whatever it is. So I will just copy everything we just wrote, all the filters, and all the filters for platform and for configurations, and I'll just tack it onto the end of this one. Let me just make sure that I've copied it properly. Yep, that should do it. And so, so that's just now I have the ability to check against these in both projects. So that should be all we need to do. Let me just geneseln and see if it complains. It doesn't, so I think that's easy. I think that's done. So let's just test it. So I think what I'll do is maybe I'll have the engine like return or maybe just print something like, I don't know, get info. And it'll just check against all of those preprocessor defines, and I'll just see what it says. So switching to Hippo, to engine.cpp, I'll just create that. So void get info, and again, because it's preprocessor defines, they're already defined at the project generation stage. So I don't have to I don't have to include anything specific. They're there already, so I can just start using them. So maybe I'll just do so an if def. If we're hippo config debug, and then end if. I usually like to, there. And then we'll just see out configuration debug. handle, right? And then I'll do the same for release. And I guess Visual Studio Code doesn't pick up on the VCX proj file that tells you that we're in debug because it's sort of hiding these. This is where we probably should start coding in Visual Studio, but that's fine. I'll just finish it here. We should still be able to see these sort of be printed out. So again, I'll do a hippo, this time a hippo platform Windows, and I'll say platform is Windows, Linux and Mac. And that's it. I think I just want to verify that these preprocessor defines are working correctly. So if I run this, I should see debug Windows, right? And so now that I've exposed this in the header to any client that might be using my engine, I can now just go to main and just call it. So maybe after hello YouTube, we'll just say hippo get info, and let's run that. Build a salon, run. Okay, that didn't work. Yeah, okay, I haven't included IOStream in engine.cpp. So I'll do that. Let's try that again. There we go, and yep, there we go. So configuration is debug and platform is Windows. What I do want to do is just check the release. So if again, I don't have a good way for the script to currently sort of take in an additional parameter or anything, but I think I did add in my build SLN. So here, I'll just change this to release, and let me just build and run again. Oh, well, run is still going to run the debug version, but I should have a release folder. Yeah, and you can see again, because we turned off that symbols, we're not generating any debug symbols alongside it. And hippo.exe, so if I just, and yeah, I can't double click, so let's just run it from here, bin release hippo editor, hippo.editor.exe. Oh, did we remove our system.pause? Yeah, we did. So let me just open PowerShell /hippo editor.exe, and yeah, there we go. So we can see hello YouTube, it's release on Windows, and this is great. So this means that if I wanted to add additional like debug prints or debug functionality that I don't want packaged in my real build, I would just wrap it in an if-def to make sure that we're not in release build. Okay, so that's good. That's working. And that's really it for this video. I really just wanted to have that distinction between the projects, because now we can start doing things like adding additional sort of projects that we rely on. For example, we're going to use SDL2 as our windowing and input library. So we're going to want that, and we're going to want to obfuscate that behind our Hippo engine. So it will have a Hippo window or a Hippo sort of keyboard event, and that'll be what Hippo Editor deals with. Hippo Editor should not be dealing with SDL directly. So that's it for today. This sets us up nicely for the future. So until next time, thanks for watching.